Hey everyone! I would say that there are never enough post-processing effects, and it's good to have as many options as possible when deciding which would fit best for our game. This time, I've prepared something simple again that fits into a few lines, yet the result can be quite interesting, especially if we are not averse to some psychedelic effects. Let's take a look at how we can implement a simple radial blur. I know I repeat this introduction almost every time, but if you haven't seen any of the previous videos, it will definitely be helpful to create a new scene with an image in the background again. So let's get into it. Right click on the scenes, create new scene, and let's call it Radial. Okay. And now the picture is here. I'll drag it to the scene. So the sprite 2D node was automatically created, and in the inspector, let's open offset and disable centered. Then let's open transform and disable position. Revert it to 0, 0. And that's exactly what we wanted. Last thing, we need to set up the shader material, of course. So let's open it here. Create new shader material, click it, and new shader, which is called Radial GD shader of the canvas item type. This is correct, and I will just put it to the shaders folder and create, and click it again to open it in the editor. Let me just expand a little bit. And as usual, we'll delete everything that isn't needed, so we are left with just the fragment function. Deleting vertex and deleting light. Okay, what uniform parameters we will need this time? Radial blur, as the name suggests, must have a center from which the blur will spread across the rest of the image. Additionally, we need to define the power of the effect and also the number of iterations we will use for its calculation. So, 3 parameters that I will write into the code now. Let's do it. So, uniform, vec2, center, and let's put the initial value to the center of the image, 0.5, 0.5. Okay, the second one would be the power. Uniform float power with a hint range, and the initial value I will set to 2. And now we want the blur in both directions, like expanding and collapsing. So let's make the hint range from -10 to 10 with a step 0.01. And the last parameter, uniform float iterations, a hint range, and we will start at 10 iterations. Okay, and from 1 to 20 with the step 1. You may wonder why I sometimes define iterations as float and sometimes as integer. I do it as float only if we need this number in calculations, because otherwise we would have to do some kind of casting from integer to float. But in some other cases, we're just iterating and not using the index in any calculations, and at that case I can just use integer. Basically it doesn't matter because the GPU is fast enough to do both types very with great performance. Okay, so now we move on to the fragment function. First, we want to determine the direction of the blur for the current pixel, which we'll achieve by subtracting its coordinates from the coordinates of the effect center, like this. So again, as usual, we'll start with defining the UV coordinates. Again, there is no shift to the center this time because we will define our own center of the effect. And the vector 2 therefore direction is, as I said, center minus UV. This is our direction. In addition to the direction, we also need the power, and since it's too high a value in this range, we will divide it by 100, which corresponds to multiplying by 0.01. Vector 2 blur is direction times power times 0.01. Please note that we are not normalizing this vector, so the power, the direction will be actually a bigger vector when it's farther from the center. This is intentional, but of course if we want just an effect that doesn't depend on the distance, we would normalize the vector. Okay, and we can blur. The algorithm consists of starting from 0, which is black, and in each iteration we will add pixels offset in the direction of the blur. We then divide the result by the number of iterations to prevent the image from being overexposed. And that's really it. There is nothing more to it. So let's code. Vector 4 color is, as I said, we start at 0, so it's vector 4 with all components equal to 0. And now the iterations for float I from 1 to number of iterations, and I++, we add a new value to the accumulator, to the color variable, and it's simply the color of the pixel of our texture at the current UV coordinates. And for the next iteration, we will increase the coordinates by the blur vector. That's it. And as I said, first, let's see what happens if I don't do it. So color is color. Wait for it. Okay, definitely overexposed, so that's why we need to normalize the final value. Color is divided by the number of iterations. Wait, now it's correct, and we are done. Let's just see the whole picture, almost. We can try moving the center of the effect in the inspector, which will create an interesting, almost three-dimensional effect. Let's do it. So I'll just move the x coordinates to the right or to the left, and the y down, up. Very interesting. Of course, we must not overdo it. Otherwise the original image will be unrecognizable, especially if we play with the power parameter in both positive and negative values. Let's try it. If we increase the power, yeah, that's definitely something maybe beyond recognition, and move the center. Let's put it to the other direction. Okay, not bad. Very well. And of course, number of iterations. What if we switch back to 1? Nothing happening, but 2, 3, 4, 5, 6, 7, 8, 9, 10, or 20. Even more blurred. Great! That's it. Thank you for watching. For practical use in the game, it will definitely be better to control the parameters using a script, allowing for a smooth transition from one scene to another, or simply from the current scene to the void. In any case, we have a lot of room for experimentation, because the existing code only performs the most basic operations, so we don't need to be afraid to spice it up with more complex functions or combine it with another shader. Anyway, that's all for now. I wish you a wonderful rest of the day, and I'll see you in the next video.